Welcome back to episode 44. We're going to talk about avoiding try-catch. This is part 2. This is an extension of episode 43. And in this case, we're going to revisit our try-maybe function that we created. So rather than having it all split up, I've got it all nice and concise here. So we've got a try-maybe function, which is a queried function that takes a function and an argument, tries to perform the application here of f of x, and then wraps the thing back up in a maybe, or wraps the result of that function application up into a maybe. And if there's an exception, then we return maybe nothing. And what that gives us now is that we can pass a function, in this case to upper, it could be any function, to try maybe. And then we can call maybe to upper, and we can pass hello, and we get hello, and we can pass an undefined, and we get back at nothing. And the cool thing there is that we've solved that whole try-catch pattern. We now have encoded the concept of this try-catch into our code. The people calling into someone who wants to call maybe to upper doesn't have to worry about try-catch. That problem is solved for them. And they can be certain that what they're dealing with is not going to throw exceptions because we've wrapped this up in try-catch. So all of those things are really good. The problem, though, is this doesn't tell us, if let's say that I'm going to log something to a file, I just get nothing. I don't know why I don't have something. It just gives me nothing. So what can we do about that? So it turns out that's where either is going to come in. And so if we look at bringing in either, so here we brought in maybe from Ram to Fantasy. Down here we're going to bring in either. These two concepts exist in many, many languages and are not unique to Ramda or Ramda Fantasy. But in the try either case, you notice it's almost exactly the same. We're going to try to perform this f of x, add it to the result, and then we're going to return either of rather than maybe of, which we had up here. Right? Maybe of, either of, because we want to return an either in this case. But what's neat is that what we can also do is then if we have an exception, we can just pass that exception in the left of either. So either is either a right or a left, and of is just kind of shorthand syntax for saying give me the right of an either. And so we can actually end up using this exactly the same. We can say either to upper. This either to upper function is going to be the result of supplying the to upper function to our try either function, which we can do because we're queried here. Then we can call either to upper with our hello, and we get a right instead of a just in this case, but we get a value that's hello. We can say either to upper, we can pass undefined here, and rather than just getting a nothing, we can now get the actual exception that we had inside of here, so we haven't lost any information. See, in the maybe case up here, we had access to this that, depending on what we're doing, could provide us some value from a debugging standpoint, from a logging standpoint, and we basically had lost that here. We basically eliminated that data from our system. But in this case, what we're able to do is really kind of cool because we're able to keep that exception data, preserve it, and just pass it on the left side of this. So what's interesting is that either, just like maybe, is a functor. It's an applicative, it's a monad. So we can do all of the cool things like we can map, we can apply, we can chain, we can lift. We do all those neat things that I've shown in other videos that we would do with a maybe or a future or an IO or any of those other things. Try either adheres to all of those kind of things. So it can be kind of scary to say, well, now it's returning this right thing versus a left thing. I don't want to have to deal. Why do I have to know about all of that stuff? For the base cases, you probably won't have to, because if you wanted to do something with the return of this, you could just map into it, and then the map is only going to work on this right case. So you can just forget that there's an error happening. That error will pop out at the end when someone, at your application boundary, you can deal with that. Or you can. There are some other things that you can use to actually deal with values that end up in the left case. But hopefully this shows the concept of this is why you might want to use We're still avoiding writing a whole bunch of try-catch stuff everywhere because we've centralized that. We have that in a singular function now. Well, actually, we have it in two functions. You get to choose which one you want to deal with. The maybe instance is going to basically forget about data that it might have had access to that might help you at some point. That's a design trade-off that there's not really a right or a wrong answer necessarily. It'll depend on your context. But then in the either case, we actually get to preserve that exception if one is thrown inside of our left, but we're still able to go through and everything else is fine. We just end up keeping this data. So if you want to keep track of exceptions or some other data, either is really cool. And another way to think about this is to say that maybe is a very, very special case of either, where the left case is just unit or void, depending on what language you're coming from. So hopefully that provides you some intuition. This has been episode 44, Avoiding Try-Catch, and I'm going to call this a part 2 as an extension from yesterday. Hope you enjoy it. Thanks.